Hello there. This is 3-7, Algebra 1, 7th period, 3-7, Part 2. Oh, my hair's a little messed up there. I gotta be careful. Part 2, 3-7, and this is absolute value inequalities. So, what's an absolute value inequality? All right, so our goal is to solve absolute value inequalities and graph the solutions. So absolute value inequalities are really hard, but you can do them. So they are in two forms, okay? There's two forms. And one of them is the absolute value of A is less than B. So the less than sign. Now, what this means is, okay, what this means is the absolute value number is smaller than, so it squeezes the number in there. It squeezes all of the values that are smaller than the absolute value. So what this means is you're going to split into AND problem. So this is a compound inequality that splits like this. Whatever's inside is less than B and greater than negative B. So we drop the bars and split it into a AND inequality, a compound inequality. So really that means the graph is an AND inequality, so it's the two values on the positive and negative. And in this problem, they're going to be open circles, and it's in between, so it's A is less than B and greater than negative B. So there's two forms. The first form is the absolute value of whatever less than B means that you split it into an AND problem because it squeezes, okay? A is squeezed, I like to say. Gently squeezed, okay? So there's one, and then two is the absolute value of A greater than B. So it's bigger than, so it's outside the B's. So A is either or. A is outside of B. Smaller than the negative, bigger than the positive. Okay, so it's smaller than the, bigger than the positive or smaller than the negative. So this is A is pushed away. So this turns into an OR problem. This is split into OR. Now, this is split into OR and the absolute value is dropped. So A is bigger than the positive B, or A is smaller than the negative B. So that graph looks like this. This is B, and it's bigger than the positive, see? And this is the opposite of B, and it's smaller than the negative. So A, the absolute value of A greater than B is pushed away. And the absolute value of A less than B, it's squeezed in there. All of the solutions are squeezed in there. So let's take a look at a few examples and what that looks like. Okay? So example 1. Now, I'm going to write the absolute value of 8 times n greater than or equal to 24. Okay? So this one is going to be pushed out because it's greater. It's greater than 24. So we're going to be pushing out here. Push out. And then this is an OR problem. So it's going to be an OR problem on the outside of that 24. So we split into OR. All right, so we write absolute, or not the absolute value, we drop the bars, 8n greater than or equal to 24, or 8n less than or equal to negative 24. Now we got to solve both of these, so I divide both sides by 8, and I get 8 greater than or equal to 3, not 8, n greater than or equal to 3, or divide by 8, n less than or equal to negative 3. Okay? So this problem is pushed out because it's pushed out 8 times a number is greater than or equal to 24, the absolute value of that number. So it's going to be pushed out. So the graph, here's 3, and I'm going to fill this one in because it's less than or equal to, greater than or equal to, and here's negative 3. So the OR problem, n greater than or equal to 3, or n less than or equal to negative 3. That's that part. So that's really what you need to do. You got to remember that if it's greater than or equal to, then it's pushed out, like bigger. If it's less than or equal to, then it's pushed in or squeezed into. Okay, like this. Squeeze, absolute value less than is squeezed in. Okay, so let's move on to another example. We're going to keep going. And another nice one might be the absolute value of n minus 1. All right, less than 2. All right, so this problem is less than. This is an absolute value inequality. So absolute value inequality. So I'm going to recognize that this is less than and this is squeezed in there. So we write n minus 1 less than 2, and this is squeezed greater than negative 2, like that. So this is less than, which is squeezed in. Now these are hard because you've got to remember a lot of rules, but if it's less than, we squeeze it. Now I've got to solve this. So this is 2 inequalities here. So I'm going to add the 1. And I get n less than 3 and greater than negative 1. So the graph of this looks like this. This is going to be, I'll put a 0 in here, and then I'll put a 3 here, and then a negative 1 here. So I'm going to have an open circle here, an open circle here, and it's squeezed in there. So it's got to be in between. So the solutions are in between negative 1 and 3, right? So if I put this into the absolute value bar, any one of these numbers will give me a true inequality for this inequality here. So less than is squeezing in, and the absolute value is smaller than. Remember, it can have positive and negative for absolute value. So if it's less than a number, then it's squeezed in. If it's greater than a number, then it's pushed out. Okay? So let's look at another example. And, excuse me, something that, it gets a little tricky, it gets a little complicated, but not too bad. So I'm going to do the absolute value of 2 times f plus 9 is less than or equal to 13. the absolute value of 2f plus 9, absolute value, less than or equal to 13. Now, this is a less than, so this is squeezed in. So we're going to squeeze it. All right, and it's an and problem. So I then split it into two. I do 2f plus 9, drop those absolute value bars, less than or equal to 13. Now on the other side, it's going to squeeze in there. It's going to squeeze negative 13 in. Now, if we solve this, we get 2f here. Subtract the 9, subtract the 9. Okay, I get 2f less than or equal to 4, greater than or equal to negative 22. I divide by 2, and I get negative 11 here. F in the middle, squeezed in, less than or equal to 2. And so the graph of this looks like this, where negative 11 is way down here, 0 is here, and 2 is about right here. Okay? These get filled in, these negative 11 and 2, because F can equal them. Now F is squeezed in, so it's smaller than 2 and greater than negative 11, so it's squeezed in between them two, between those two numbers. Okay, let's do one more example. We'll call it a day. This is example 4. And we'll do 4w, absolute value of 4w plus 1, greater than 11. This problem is a greater than problem. It will be pushed out. All right? So you're going to push it out because it's greater than it's the absolute value of some number is greater than 11. So it's going to push out. All right, so let's do it. We're going to split it. So we do 4w plus 1 is greater than 11, or remember, or is the push out. The graphs go out, or 4w plus 11 is less than, or 4w plus 1 is less than negative 11. Okay? So we're going to solve each one of these. We get 4w is greater than 10, divide by 4. So w is greater than 2.5. Greater than 2.5. You're going to subtract the 1, and you get 4w less than negative 12, or w less than negative 3. All right, so the graph, put 0 right here. Let's do negative 3 down here. 2.5, a little bit closer to 0 than negative 3. These are both open circles. So this is an OR problem, so this is pushed out. Let's read it. W greater than 2.5, which is these numbers to the right of 2.5, or W less than negative 3, which are these numbers pushed over negative 3, pushed outside of negative 3. So absolute value inequalities, we remember there's two forms. It's either going to be split into an and, it's squeezed. The second form is going to be pushed away, and it's split into an or problem. Okay, and we went through four decent examples. Okay, there's 1, 2, yep, example 1, example 2, example 3, example 4. Okay, have a great day, everybody.